In our previous video we talked about GPS jamming, spoofing, and even hacking risks at sea. But now the real question is, what happens when it actually affects your ship? Let's understand this with guidance from Captain Prashant Kulkarni. Do you really know where your ship is? Now imagine this, your satellite navigation suddenly fails. Your position disappears from the ecdis. Or worse, it shows your ship somewhere impossible. You haven't moved, but your system says you have. This is what happens during GPS jamming and spoofing. In that moment you can't fully trust your position. And at sea, that can be dangerous. GNSS has always been reliable and accurate. But today that reliability is changing. In regions with conflict or instability, GNSS signals are becoming less dependable. Let's look at some real-life cases where this has already happened. Here's a real incident from the Red Sea. A vessel lost its GPS signal and started navigating using estimated position on ecdis. Hours later, the crew noticed a strange change in sea color. They thought it was seaweed. But it wasn't. It was a coral reef. The vessel ran aground at 11.3 knots, causing serious damage to the ship and the reef. Later, authorities used the IMO LRIT system and found something shocking. The vessel was actually over 40 nautical miles away from its displayed position on ecdis. This is how GNSS jamming or spoofing can mislead a ship and lead to serious accidents. Another real incident. In 2019, the oil tanker Stena Impero was seized in the Strait of Hormuz. Reports suggest the vessel's GPS was spoofed, misleading its navigation system. The ship was unknowingly diverted into Iranian waters, where it was then boarded and captured. This shows how spoofing can not only confuse a ship, but also put it into serious danger. A more recent example. In October 2023, the Israel Defense Forces announced that GPS signals were restricted in active combat zones. This was done for operational reasons. Then in April 2024, researchers from the University of Texas detected false GPS signals in the region and traced them back to a military air base. This shows that GNSS interference can be deliberate and used as part of modern warfare. In 2017, around 20 ships in the Black Sea reported wrong GPS positions, showing them miles off course. Experts believed it was a spoofing attack. Similar incidents were seen near key locations in Russia. With systems like Borisogledsk 2, Krasuka, and Zittel linked to such capabilities, this shows how widespread GPS spoofing can be. Here's another real incident. A 2018-built oil tanker was approaching port in Sudan when it experienced severe GPS spoofing. After berthing, unusual tank readings suggested water ingress, but no leaks were found initially. Later, during inspection in Chennai, a 5-meter rupture was discovered in the forepeak tank plating. The vessel was repaired in Singapore and fortunately, there were no injuries or pollution. Another case. In 2017, around 20 ships in the Black Sea reported GPS positions showing them miles off course. Experts, including Professor Todd Humphreys, believed this was a spoofing attack. At the same time, similar GPS disturbances were seen near key locations in Russia, suggesting spoofing was being used deliberately. Systems like Borisogledsk 2, Krasuka, and Zittel are known to have such capabilities. More incidents have also been reported. In 2018, during a NATO exercise in Finland, GPS interference was linked to a ship collision, though not officially confirmed. In 2019, spoofing signals from Syria affected a civilian airport in Tel Aviv. And in 2022, heavy GPS interference was reported across several Russian cities, likely as a defensive measure. So, what do we learn from these cases? GPS interference is real, especially in high-risk regions. It can make your main navigation system unreliable. In such situations, officers must take critical decisions, often with very different outcomes. Never rely only on estimated position on ecdis if GPS data is doubtful. And always use alternative systems like LRIT to confirm your actual position. Because at sea, knowing your true position is everything. Here are some key best practices. Never rely on just one positioning system. Always be ready to use manual plotting, radar, and dead reckoning. If something feels wrong, reduce speed and increase bridge monitoring. And most importantly, share information across the team. Because even today, traditional navigation skills are essential, and redundancy is the key to safety. These cases show how dangerous GPS jamming and spoofing can be, but what really matters is how you respond. In part 3, we'll cover the steps every officer must take to stay safe when navigation systems can't be trusted. Stay tuned for part 3. If you found this useful, don't forget to like, share, and subscribe.